so we'll continue the portion. So again, here one, okay, man thinking what's going there, what's going in the mind of this man. We need to talk about that. So what I am talking, adds up, okay, adds up, adds up, adds up, okay, yeah. So we'll play with some dimensions. We'll play with some dimensions of some physical quantities. So first play with dimensions, okay. So if I'm talking about dimension of speed, so what is dimension of speed? Dimension of distance divided by dimension of time. Dimension of time, okay. So what is dimension of distance? L by dimension of time t. So what is dimension of speed? Lt minus 1. What is dimension of velocity? Dimension of velocity, as I already said, okay. So this will be displacement divided by dimension of time. So what is dimension of displacement? Can anyone say over here? So dimension of displacement is again L by t. This is Lt minus 1. Acceleration, what is dimension of acceleration? Can anyone tell me dimension of acceleration? So acceleration is what? Dimension of change in velocity, okay. Change in velocity divided by again time. So can I use the dimension of change in velocity from here directly? So this is Lt minus 1. Velocity or change in velocity dimension have, both dimensions are same, okay. Both have same dimensions, okay. So I'm using, in place of change in velocity, Lt minus 1. So I'm putting this value here. So divided by time t. So answer will be Lt minus 2. Clear? I'm using this Lt minus 1 by t. So this is Lt minus 2. Is it clear? Is it clear to all of you? Please respond me. Okay, is it clear? Is it clear to everyone? Hello, hello, hello. Is it visibility is good or not? Okay, hello, hello, hello. Yes, now it's good. Okay. Hello, 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 hello. Clear? Yes. So moving forward, okay, moving forward. So moving forward. When I'm talking about dimension of, okay, what? Force. Okay, so let's play the dimension of force. So force can be written as, okay, dimension of mass into dimension of acceleration, So yeah, so I'm using dimension of mass as capital M. Dimension of acceleration I already did over there, so I'm using that values, that is Lt minus 2. So I'm putting that values directly. You can do step by step, velocity by time, again distance by time, and all this, okay. So this is what? Acceleration Lt minus 2 now. So what is this? M L T minus 2. So dimension of force I have done. Next is dimension of torque. So if you don't know, don't worry about it. I will explain it again, or you can go with past sessions. I had already covered all syllabus. Okay, I had covered all syllabus. Okay, for your, okay, point of view. So I had covered everything over there. So you can go through it. If you don't know, you can go through it. Definitely you should go. If you know, it's okay. If you don't know, again you can wait for next session. Don't worry, I will explain it again. Okay. Basically torque. So I am writing this simply for the sense of ending or dimensions. So dimensional point of view I am writing over here. So this is what, can I say directly? So basically this is what this dimension of displacement into dimension of force. So what is dimension of displacement here? Dimension of displacement is L. What is dimension of force? M L T minus 2. So what is dimension of torque again? M L 2 T minus 2. Is it clear to all of you? Everybody please respond me. Is it clear to everybody? So again I am talking about energy, dimension of energy. So dimension of energy is what? Again force into displacement. So dimension of force I am writing over here. Dimension of force, dimension of displacement I am writing over here. what is dimension of force? ml t minus 2, ml t minus 2. What is dimension of displacement? L. What is this? ml2 t minus 2. Is it clear? So from here, what can you observe? The dimension of torque and dimension of energy are same. Okay, so dimension of torque and dimension of energy is same. You can keep this thing in your brain. Okay, you can keep this thing in your brain. It's very useful. Okay, it's very useful. Is it clear to everyone? Is it clear to everyone? Yeah. Let's go. Let's go. So I covered dimension of energy. I covered dimension of energy. So if I will ask you what is the dimension of power, can anyone explain over here what's the dimension of power? So dimension of power is basically dimension of energy divided by dimension of time. Am I right to all of you? So what's the dimension of energy? I already did over there. So I'm writing directly ml2 t minus 2. I'm writing directly. You can go step by step again. I'm saying okay. By t. So this will be what? ml2 t minus 3. Okay. See, if I'm talking about energy, so either energy is kinetic or potential. Both all energies have same dimensions. Is it clear to all of you? Energy stored in capacitor, energy stored in inductor, all have same energy. Okay, so all have same dimensions. Is it clear to all of you? So I'm writing here because it's important. So in the dimension of energy equals to dimension of kinetic energy, or even a dimension of change in kinetic energy. So I already discussed that points earlier, so I'm not touching that points again. Equals to dimension of potential energy. So what's the dimension of all this? Again, this is ml2 t minus 2. Is it clear to all of you? Is it clear to all of you? Okay. Now, what's the dimension of spring constant? Okay. So dimension of spring constant. Okay. Constant. Okay. So what's the dimension of spring constant? So you all of you know F is what? If you don't know, don't worry. Okay. So this is spring constant. So F by X. Okay. This is basically what? Dimension of F. Dimension of force divided by dimension of displacement. Okay. Okay. So what's the dimension of force? Okay. ml t minus 2 and divided by L, displacement. So L cancel out. So basically what is this? m t minus 2. Is it clear to all of you? Please respond me. Okay. Is it clear to everyone? Hello. Is it clear to everyone? So there are so many ways. Okay. So many things we need to find out the dimensions of that. Okay. So we are taking 2-3 more examples. After that, we will go for next concepts because I have to cover these chapters now. Or I'm leaving it, okay, because I have to cover this portions. So yeah. So I'm going for next topics because I have to cover it now. Okay. I have given so many days for this chapters. It's not good for us. So I have to close it over here. I'm posting for next topic because I have to complete the portions as soon possible. I have given already so much of time. Okay, I have given already so much of time. So we have to move. Forward. Yeah. So I have to move. Okay, I have to move on. So I'm moving forward because I have to complete the portion. So I'm going for next concepts. Okay. So see, if I have to check an equation is dimensionally correct or not. Okay, suppose I'm taking examples. By example, we'll try to understand the thing. Okay. So what basically I'm trying to do? Equation is dimensionally correct or not? Equation is dimensionally correct or not? Okay, correct or not? Okay. So suppose if I take s equals to ut plus at square. Okay. If you check it, okay. So if you check it, so dimension of s. See, basically what's the rule? Rule is that if all the terms is in addition or subtraction, so all the terms should have same dimension. Then only you can add or subtract. Okay. In multiplication division there may be different dimensions, but in addition or subtraction there must be same dimension to add or subtract. Okay. So I'm writing here there must be same dimension, must be same dimension, must be same dimension, must be same dimension, okay, to add or subtract, to add or subtract. Is it clear to all of you? So if you want to add or subtract, there must be same dimension. Clear? There must be same dimension, okay. If you want to add or subtract, there must be same dimension. If there is no dimension is not same, you can't add or subtract, you can't add subtract. So here if I'm adding, I'm saying this equation is okay added, okay, dimensionally. So try to find out the dimension of all the terms. So what's the dimension of s? So dimension of s is here L, okay. What's the dimension of ut? What's the dimension of ut? So dimension of ut is dimension of u into dimension of t. So what's the dimension of u? So lt minus 1. What's the dimension of t? T. So again this will become L. So see, this is L, this is L. I try to find out dimension of AT square. So dimension of AT square. So what's this? Okay, dimension of A and dimension of T square. Okay. So dimension of A is what? LT minus 2. LT minus 2. What's the dimension of T square? This is T2. Okay. So again this is dimension of L. So see, again this is L. Okay. So here is dimensionally L. This is dimensionally L. This is dimensionally L. Okay. So dimensionally this equation is correct, but is the equation is correct? Okay. Is this equation correct? No. What's the correct equation? What's the correct equation? Can anyone explain me? What's the correct equation? Correct equation is s is ut plus half at square. Okay, this is correct equation. So but dimensionally correct, what does it mean? Meaning that okay, if equation dimensionally correct, it doesn't necessary that equation will be correct. Okay, equation may or may not be correct. Okay, so if equation is dimensionally correct, okay, if the equation is dimensionally correct, so equation may or may not be correct. Am I right to all of you? So write this point. So what I am saying over here, if the equation is dimensionally correct, equation may or may not be correct, okay. Okay, so means dimensional analysis, if the equation is dimensionally correct, does it, okay, is it necessary that equation will be correct? No necessary. Okay, so if the equation is dimensionally correct, so it doesn't give any guarantee. Okay, so dimensionally correct doesn't give guarantee. Okay, so doesn't give guarantee. Am I right to all of you? Doesn't give guarantee. Okay, doesn't give guarantee that equation will be correct. Okay, this is one thing you should take care in your brain. Okay, next thing is that what I am saying, if the equation is dimensionally incorrect, okay, then must be incorrect, then equation must be incorrect. Okay, so if dimensionally incorrect means incorrect, with dimensionally correct may or may not be correct. Okay, so if the dimensionally incorrect, then must be incorrect. Okay, so if dimensionally incorrect, then must be incorrect. Right to all of you, must be incorrect. Okay, must be incorrect. Okay, so the equation is dimensionally incorrect, then must be incorrect. Is it clear to all of you? If the equation is dimensionally incorrect, then must be incorrect. Is it clear to all of you? If the equation is dimensionally incorrect, then must be incorrect. Is it clear to all of you? Please respond me fastly. All the points are very important. What I am discussing, please take care of all points if you want to grow. Yeah, so I'm moving forward. So this was dimensional analysis. So one, you should take care of all the points. I'm not repeating all the points because I have to cover whole portions. I already gave sufficient time for this chapter, so I have to move on for next chapters as well. So that's why I'm moving forward, so I have to leave it over here. So I'm going for next concepts. Okay, hope you understood what I am saying. Okay, Yeah. So next, first thing first. Okay. Our logo. Okay. Have a slogan. So start. Yeah. Next, first thing first. What's the next? What's the first? Next thing next, first thing first. What's the next? What's the first? Nothing is next. Nothing is first. You are next. You are first. Thank you. Thank me for arms. Okay, and clap for me, please. Clap for me. I'm just kidding. Yeah. Anyway, so what I'm saying. See, if I'm saying any physical quantity, depends on different physical quantity, different parameters. So you can find out the relation. Am I right to all of you? You can find out relation. You cannot find out the value of constant, but you can find out the relation. Is it clear to all of you? Please tell me. Is it clear to all of you? Please tell me. Suppose if I'm saying, okay, coefficient of viscosity. I'm taking example, coefficient of viscosity, coefficient of viscosity, coefficient of viscosity. Okay, coefficient of viscosity depends. Okay, coefficient of viscosity. Suppose coefficient of viscosity depends. Okay. Let's take simple example first. Okay, so I'm taking okay, other examples. Okay, suppose I'm saying okay, what, okay, energy depends on force and displacement. Okay, so energy depends on force and displacement. So find the relation between energy, force and displacement. Find the relation between energy, force and displacement. So I don't know anything. I just know that this is E for energy and this is force is F, and this is displacement is for D, suppose. Okay, so I will write over here. So E depends directly proportional. Putting first directly sign of directly proportional. So it depends on force power A and D power B. Is it clear to all of you? So this is on energy depending on force power of E, energy depending on displacement power B. I don't know any relation. I'm trying to find out the value of A and B. Once we find out the value of A and B, I will put the value over here, and again I will put the values. Is it clear to all of you? Basically now I'm writing like this: E is F of A and D of B. Okay, so basically you have to do it dimensionally. Okay, so do it dimensionally. So this is dimension of energy, dimension of force, and dimension of D. So what's the dimension of energy? All of you know, ml2 t minus 2. What's the dimension of F? ml t minus 2. Okay, and power of A. And what's the dimension of D? L power B. Now see, you can do step by step and you can do as you want. Okay, so just see what I'm doing. So this is basically what m power A, L power what A plus B, and T power minus of 2. Is it clear to all of you? So from here, see, m power A is here and m power 1 is here. So what's the A from here? So A is 1 from here. Is it clear to all of you? Is it clear to all of you? A plus B is 2. So you can compare the equation. A plus B is 2. So A plus B is 2. Okay, A is 1 already. So put a value of A 1. So what's the B? B is 1. Okay, so basically what I am obtaining over here, A is 1, B is 1. A is 1, B is 1. I am putting this value over here. So what's relation now I am getting? E is equals to F power 1, D power 1. So basically E is equals to F into D. So basically this is the relation. Yes or no? This is the relation. Is it clear? Is it clear? So by this way you can solve the questions. Okay, you can take any questions, no matter. Okay, matter is that you have to follow the same concept. Is it clear to all of you? Please clap for me if the concept is clear to all of you. Okay, please clap if the concept is clear to all of you. Okay, so error. If I'm talking about error, so what's the meaning of error basically? So we take the value, difference in value from true value. Okay, so measured value, okay, from mode of measured value, okay, minus of true value. Okay, I'm talking about mode. Okay, so this is difference. Okay, so you can take over here mode. Okay, so this difference is basically error. Am I right to all of you? So what's the error? Error is the difference of measure value and true value. Error is the difference of measure value and true value. Is it clear to all of you? So error is the difference of measured and true value. No issue. And I'm considering mode over here. Okay. So basically, error is what? Delta E. This is error. Okay. Delta E. You can also say this is basically what? E of mean minus of E of mean minus of E of I. So we'll go for it. Don't worry about it. Okay. Just I'm writing like this. Okay. A of mean minus A of I. Basically what we'll do, A of mean minus A of 1, A of mean minus A of 2, so on, so on, so on, so on. How we got A mean is basically sum of all data divided by n. Okay, so A mean is what? A1 plus A2 plus A3 divided 3 data divided by 3. This is A mean. Okay. So afterwards, I am finding out difference. This difference is what? Difference division of A1. So this is delta of A1. So this is delta of A1. This is one way. Okay. There another way also. Don't worry about it. Okay. So this is the mean method. From there we are finding out deviation from mean. We are finding out deviation from mean. Is it clear to all of you? Please clap for me. Okay. So here I am trying to do deviation. So this is error. This is error. This is all about error. Now what I am talking about, what's the relative error? Can anyone explain me? What's the relative error? Can anyone explain me? So basically relative error is error. Suppose error is delta E divided by actual error. Okay, delta E by E. This is okay, relative. So what's the relative error? So if I am talking about relative error of this, what's the relative error? Delta A1 by A1. This is the relative error for A1. So delta A1 by A1. This is relative error for A1. Am I right to all everyone? Am I right to everyone? What's the relative error for A2? Can I say delta of A2 by A2? So if I'm talking about their original value to their error, so that's the relative error. Now, what's the percentage? What's the percentage error? Can anyone explain over here? So what's the percentage error? Percentage error. So no, nothing to do with it. Just multiply by 100. Just multiply by 100. So once you will multiply by 100, you will get percentage of error. Okay. So what's the percentage of error? Delta E by E into 100. Is it clear to all of you? Please clap for me. Is it clear to all of you? So basically what I am talking about percentage and percentage error is for delta E divided by E into 100. Is it clear to all of you? Please respond for me. Please clap for me. Yeah. Is it clear to all of you? Yeah. So this is delta E by E into 100. So this is percentage error. If I am talking about percentage error for A1, so delta of A1 by A1 into 100. If I am talking percentage error of A2, delta of A2 by A2 into 100. Is it clear to all of you? Please clap for me. Please thank me if the concept is clear to all of you. Please respond me, okay? Because I have to move on. I have to complete the portion. So we are almost to do the complete the portions. Yeah. Next thing is that okay, when there is error, so what's the basic thing? I'm taking examples. By examples, I'm going through it. Okay, then you can do any questions. Okay. So see, error, we always add error. We always add error. We never subtract error. Okay. So error is always added. Take care of this thing in your brain. Everybody, please. Okay, error is always added. Is it clear to all of you? So error is always added. Error is always added. Please take care of this thing in your brain. Error is always added. We never subtract error. Okay. I'm taking example. Suppose this is A1. A1 is what? 5 plus minus of 0.2%. Okay. So basically, what is this? What does it mean? Means error of 0.2. This is absolute value. This is error. Percentage error. This is absolute value. This is percentage error. Okay. I'm writing over here A2. 2 plus minus 0.1%. Okay, so this is again error, percentage error. This is absolute value. This is percentage error. This is absolute value. Is it clear to all of you? Yeah. Now what I am doing over here? So I am taking A1 plus of A2. So I am adding both. So if I am adding both, so what to do? Add both. 5 plus 2. So see, you are adding, so you can do anything with the absolute value, no problem in it. But whenever you are doing with okay error, so you have to do always addition. Either you are doing addition, subtraction, you have to do always add. You have to always add. Okay, error. Yeah. So what I am doing over here, so plus minus. This is always 0.2 plus of 0.1. Whatever I am doing over here, either I am doing A1 minus A2. So what to do over here? Now 5 minus 2. Because you're subtracting over here, so no issue in it. Okay, you have to subtract 5 minus of 2, but afterwards you have to do plus minus. Okay, again you have to add it. plus 0.4, no changes. Okay, there is no changes in it. Okay, please, is it clear to all of you? Please clap for me. Thank you for me. Okay, give thank you to me. Okay, so this is one concept. Next is scientific notation. So how to represent scientifically. Afterwards, I will start basic mathematics where I will cover all the mathematics required for your syllabus. Okay, I will complete it today only because we are being late. Okay, so to complete it fastly, otherwise again we will be back. Okay, soon. So we have to do it. Okay. So what I am talking? I am talking about what? I am talking about scientific notation. Can anyone explain me what is scientific notation? Scientific notation. Okay. So basically, if I am saying 502, you have to write in scientific notation 5.0 into 10 power 4. Okay, write it in scientific notation 1090.2 into 10 power 4. Write in scientific notation 1072 into 10 power minus 7. So I am doing this by questions. Okay, so try to understand over here. See 502. So this you have to convert this one into what? Scientific notation. Scientifically. So what's the basic format of scientific notation? Write any number. Okay, put decimal after one digit, and convert remaining thing into 10 power something, 10 up power something. Okay, 10 up power. Write in exponent form and multiply 10 power something. How I am doing over here? This is always put decimal after one digit from left side. I am talking from left side because from right side maybe any digits. Okay, yes or no? So 5 from left side and then put here decimal 5.0. This is confirmed. You have to lock it by putting decimal from left side. Okay, no need to worry about from right side. Right side maybe any digit, depends on the numbers. Okay, about which number we are talking about. Okay, so 5.02 and this is what 10. So because you have to multiply it and come back over here, so you get the same number. So what to do? So see, you are shifting decimal from here, basically what's to from here to here. So you 10 power 2. So multiply 10 power 2. You can do it basic mathematics, you can learn it, you can practice it. Yeah, come back over here. So this is 0.5020 into 10 power 4. So what to do? So can I write this one as 5.020? So what I am doing over here, 10 power 5 4 already I have. So I am shifting decimal from this to this place. Okay, so what I have to do, can anyone help me? I have to multiply by 10 power plus or 10 power minus. So I have to multiply by 10 power minus 1 because I have to shift it back now. See, here is back. I am moving it forward. Okay, so right what? So 10 power minus 1. Is it clear? And 10 power 4 already over here. 10 power 4 already over here. Now you can simplify it. 5.020 into 10 power 3. Is it clear to all of you? Please thank me. Is it clear to all of you? Please clap for me. Yeah. So 1090.2 into 10 power 4. How to write it? So 1 point. I'm doing it fastly now because you already know point. So 2 point. No need to write point over here. Directly write 2. See, here I have to shift the decimal right side. So I have to multiply it by 10 power 3. So with decimal I'm putting here. Decimal is already here. So I'm multiplying by 10 power 3 over here. So this is 10 power 3 into 10 power 4. Is it clear to all? 1.0902 into 10 power 7. Please respond for me, please clap for me, please clear to all of you, please thank me, please support me, please clear to all of you. Yeah, so 1072 into 10 power minus, how can I write 1.072? So I'm putting decimal over here, so I will shift decimal rightwards, so I will multiply by 10 power 3. Is it clear to all of you? Yes. So 10 power 3 into 10 power of minus 7. Okay, now you can simplify it. Normally 1.072 into 10 power, this is minus 1. So this is it. Okay, see, I have to cover one more portions. Afterwards the portions will be completed, then I will start new chapters. Okay, so because I can't take another session for this chapter because not possible. So I have already scheduled everything, so I can't go out of limit. So I have to finish it. So give me some time. I'm completing it. Don't worry about it. Yeah. So I'm talking about significant figures. These very important questions comes from here. That's why I'm talking about. We cannot leave it. Okay. So significant figure. Okay. Significant figure. Or you can also say number. No problem. Significant number. Okay. So you have to count it significant number. Suppose see, I'm adding 5.22 plus 1.7. Okay. So you have to write answers. When you are doing addition subtraction, you have to write answer always in less number of digits of decimals after digits. Okay, no need to count significant figure in addition and subtraction. Listen, No need to count addition and subtraction, significant figure in addition subtraction. You have to just focus on list number after decimal. So how many number after decimal? 0.1 number. Okay, so you have to put only one digit after. Okay, same way you have to, same pattern you have to follow for result. Okay, just add it. So if you add it, so what is it? Okay, 2 9. Is it clear to all of you? And this is 6.92. Am I right? Yeah. So you can't write answer 6.92 is wrong answer. If you put the okay, so if you have to follow the significant figure rules, you have to keep it in the smallest number of digits after decimals according to the rule. So you can keep it like this. 6.9 is the answer. You can approximate it, no issue in it. I already explained approximation. If you will ask me again, I will explain it in next session. Don't worry. But I have to complete this portion. That's why I'm moving forward. Okay, yeah. So this is for addition subtraction. You have to do it same thing. Okay. Now I'm talking about multiplication and division. So multiplication and division, you have to focus on significant figure. So for that you need to count. You need to know how to calculate significant figure. So I'm going to explain you how to calculate significant figure. So see basically what is this? What is it? 502. 502. So here 0 is in between it. In between it. Okay. So no need to worry about it. No need to worry about it. Okay. So you have to count it. This 0 is countable. Listen what I am saying. This 0 is countable. So how many significant figure? 3. Now listen. If I am saying 5 2, this is already significant. Okay. You have to significant focus on significant, but there is zeros only. If we are talking about zeros only, so if number, any number 1 to 9 already significant. It's already significant. 1 to 9 is already significant. Okay. So what I am doing? How many significant figure over here? 2. Now listen. 0.0. I am putting here. First 005. How many significant? No need to count 0. Left side no values of 0. Left side no need to count zeros. Left side no need to count zeros. Okay, yeah. So how many significant figure? 1. Okay, 0.05. Okay, again no need to count this 0. If there is no any non-zero number in between, no need to count. No need to count. Okay. Again, how many significant figure? 1. But if I say okay 0.2005. Okay, so how many significant figure? 4. If I will say 0.02005, so how many again? 4. No need to count this 0. Is it clear to all of you? Is it clear to all of you? So yeah, we'll take more examples. Suppose if I say 5.20, so now you need to count this 0. Now you need to count this 0 because after decimal you have to take care of all zeros. So this is significant. So how many significant figure here? 4. Okay, 5.2020. So you can't ignore this 0. You can't ignore this 0. So how many significant figure over here? 5. So the answer is 5. Okay. So thank you. I hope all of you understood all the concepts. I had covered all the concepts. Okay. So we thank you for your appreciations. Thank you for your support. Thank you for your comments. Thank you for reviews. Thank you for everything. Thank you for your love, care, and everything. Okay, so I'm trying my best to complete all the portions. As a proof, you can see already I had completed whole syllabus one time. Okay, so you can go through it. Okay, just I'm not talking that I will complete it. I already completed one time. Okay, this second time I'm repeating it. Okay, whole syllabus again. I'm promising with you I will complete second time whole syllabus again. I don't want anything from your side. Okay, so please take care, learn, and keep going. Okay, thank you. Bye bye.